Hey, welcome back to your favorite pre-calculus class. We're going to take a look at polynomial and rational inequalities. We're going to look at this initially visually. This is saying use this function given here. And part A, find where the function is greater than 0. Where's the functional value? Where's the y values greater than 0? And hopefully you can see on the graph, I'm going to outline it in blue. That's where it's greater than 0. Now I'm not going to include the actual 5 value right there because it is equal to 0 right there. So when I answer this question, where's the function greater than 0, I'm going to name it in terms of the x values, anywhere where x is greater than 5. So from 5, but not including 5 because I don't want it to be equal to 0. I want it to be above the x-axis, right? Part B is, where is the functional value less than or equal to 0? Well, let's outline that in red. All these y values are negative, right? Less than or equal to. How about right there at -2? Yes, it is. It hits right on it. I can be equal to 0 as well, less than or equal to. So I'm hitting all these. So I name it in terms of clear up until that 5 right there. Yeah, so it's coming from -infinity, clear up to the -2, include the -2, I keep going, clear to an x value of 5, and I include the 5. So -infinity up until 5. Let's do another one visually as well. All right, here's another visual or a graph of the function f of x. Let's look at where is f of x. Where is f of x? The y value is less than 0. I'm going to trace the graph. Notice these are all negative, negative, negative. I got to be less than 0, so I don't want to include an x value of 0 there. So that would be from a -2 x value, not including. I never touch that -2 because it's a vertical asymptote. Up until an x value of 0, and I don't want it to touch an x value of 0 because I want to be below, right? Where's the y less than 0? And then I'm going to keep going. It looks like I got some more on this graph that's negative on the right-hand side here from an x value of 1 on to infinity. It stays below 0. The y values stay below 0. So that's part A. Let's do part B here. Let's do it in red. Where is this function greater than or equal to 0? Well, hopefully you can see over here I'm all positive y, so that's from -infinity up until a -2 x value. I'm not going to touch -2 because that's a vertical asymptote. And then right here at 0, I do hit 0, so I want to include 0. And then all of that up until an x value of 1. I'm not going to hit an x value of 1 because it's a vertical asymptote. So now we've looked at these visually, but we're going to do it algebraically without a graph now. So here we've got this quadratic, x squared minus 3x minus 4. Where's this thing less than 0? All right? Where is this function less than 0? This is like our f of x function, right? This is x squared minus 3x minus 4. Where is that thing less than 0? That's what we're asking, right? So if I was doing that, the first thing is I would, number one, find our critical points. What are our critical points? Bless you. Critical points are the zeros and where it's undefined. Okay, so I imagine for a minute, this being equal to 0. So, and then I find my critical numbers from that. So 4 and -1. Okay. Number 2 is, now I'm going to put this on my testing interval. -1 and 4. Now the question is, can I include -1 and 4? Well, I'm testing it in this x minus 4 times x plus 1 less than 0. Let's test these critical numbers. Can I include them? If I test -1, -1 minus 4, -1 plus 1, -5 times 0, is 0 less than 0? 0 less than 0, yes. Hopefully you say false. No, it's not. So I'm going to leave that as an open, meaning I'm not going to include x being -1 as part of my solution. Because if x is -1, that's actually a y-intercept. That's where that quadratic, and we'll make this visual in just a second, but that's where it hits the x-axis, right? So we want to be less than 0. We want to be below the x-axis. Okay, so I'm not going to include that. Now I'm going to test 4 as well. Would 4 work? Well, again, I'm going to test 4. 4 minus 4 times 4 plus 1. Is that less than 0? 0 times 5 is 0. 0 less than 0? No, that's not true. So don't include 4 either. Don't include 4 either. Okay, now that I've determined whether I'm going to include my critical points as part of the solution, now I need to test in the intervals. So I'm going to test something to the left of -1. Like let's just go to the next one to the left, like -2. Then I'm going to test something between them. What's between -1 and 4? Like 0 would be a good one, right? Between -1 and 4. And then I'm going to test one to the right of 4, like maybe 5. Okay, and we're going to test them one by one. In our original. So let's test -2. -2 minus 4 times -2 for x plus 1. -6 times -1 is 6 less than 0. False. It is not less than 0, right? So false. That's not part of our solution. Now let's test 0. X being 0. Let's plug that in. So 0 minus 4 times 0 plus 1 is -4 times 1 less than 0. Is -4 less than 0? Hopefully you say true. Yes, it is. Okay, so between -1 and 4 is going to be part of our solution there. And finally, I'm going to test 5, x being 5. 5 minus 4 times 5 plus 1, is that less than 0? Is 1 times 6 less than 0? Is 6 less than 0? No. False. It is not. So my answer is between -1 and 4. I'm not going to include -1. That's the open hole. I'm not going to include 4 either. That's an open hole. So from -1 to 4 is any x values between there makes this true. Any x value between -1 and 4, not including -1, not including 4. Well, let's think about this for a minute. Let's say that I actually graph this. This is my function, right? My function is x squared minus 3x minus 4. Well, my zeros are 4 and -1. And this is a quadratic, x squared minus 3x minus 4, a quadratic, positive x squared. So this is going to open up. Now, I'm not going to go through the whole process of finding it exactly, but can you see how this function is less than 0 between -1 and 4, right? So we just did it algebraically because they're not always so easy or friendly to graph, right? So we're just going to stick to finding the critical points and doing these things algebraically with a testing interval. All right, look at this next one here. We've got another quadratic, but the annoying thing is I don't have it one side equals 0. So make sure you get that right-hand side equals 0. Let's subtract 5x on both sides. Let's subtract 6 on both sides. So I got 6x squared minus 5x minus 6 is greater than or equal to 0. All right, that's the first thing on this one. Now the second thing is, let's go ahead and we've got to find our critical point. So let's go ahead and factor this thing. Factor this, you guys should get that factorization right there, right? And then of course FOIL it back, make sure you got the correct factorization. And the reason we're doing the factorization is we want to know where our critical points are. Our critical points are our zeros or where it's undefined. So I'm going to take that first one, set equals 0. I'm going to imagine it's equal to 0 for a minute. Subtract 2, divide by 3, divide by 3. Okay, negative 2/3 is one of my critical points, and 3/2 is my other critical point. So when I'm on my testing interval, I'm going to put on there negative 2/3 and 3/2. And then I want to decide, am I going to include those? Well, we could test negative 2/3 into the original 3x plus 2, or the factored form of this. Is that greater than or equal to 0? Well, if I plug in negative 2/3, see, I get negative 6/3, or negative 2 plus 2, negative 4/3 minus 3. I get 0 times whatever is 0. Is 0 greater than or equal to 0? Yes, or equal to. So I'm going to include that. I'm going to include that negative 2/3. When I plug in 3/2, what will happen is I'll have 3 times 2, 3/2. But when I plug it in over here, I'll get 0. Is 0 greater than or equal to 0? That is also true. So I'm going to include the 3/2. So we're going to include these zeros because we've got an or equal to with our inequality. The or equal to means we're going to include those 0 critical points, right? And now it's on to testing our intervals. So I'm going to test something to the left of negative 2/3. I would test negative 1. Something between a negative and a positive, I would test 0. Something to the right of 1.5, I would test like maybe a 2. I'm going to test these one by one. 3x plus 2 times 2x minus 3, is that greater than or equal to 0? So 3 times negative 1 plus 2, 2 times negative 1 minus 3, negative 3 plus 2 is negative 1, negative 2 minus 3 is negative 5. Is 5 greater than or equal to 0? Yes, it is. So that's going to be part of my solution from negative infinity up until negative 2/3. I'm going to include negative 2/3. Now let's throw in 0. 3 times 0 plus 2. 2 times 0 minus 3. Is that greater than or equal to 0? So I got 2 times 0 minus 3 is a negative 3. Is negative 6 greater than or equal to 0? No, it's not. That's not going to be part of my solution. Throw in the 2. 3 times 6 plus 2 is 8. 2 times 4 minus 3 is 1. Is 8 greater than or equal to 0? Yes, it is. So it looks like true, false, true. So it's anything negative infinity up until negative 2/3. Let's write our solution here. Negative infinity up until negative 2/3. But remember, we're including the negative 2/3. And then we're taking off again from 3/2, but we're including the 3/2 to infinity. Okay? And that's where this is greater than or equal to 0. If you were graphing this, by the way, it hits at negative 2/3. It hits at 1.5. And this is a quadratic that opens up. So hopefully you can see that's where it's positive, right? Including the zeros there. negative infinity up until negative 2/3, and then from 3/2 on. So here we've got a cubic instead. The process is going to be the same algebraically. We're going to find our critical points. The nice thing is this already has a 0 on the right-hand side of the inequality. So the critical points are going to be at 5, x minus 5 equals 0, x plus 2 equals 0, at 5, and negative 2 on this. And so our testing interval, negative 2, and way up here at 5. Now, are we going to include them? Well, if I throw in negative 2, I got negative 7 times 0 is 0 less than 0. No, it's not. So I'm not going to include it, right? This is strictly less than. Not going to include it. If I throw in the 5, I'm going to get 0 less than 0. So I'm not going to include the 5 either. And now we got to decide, what are we going to test? Well, let's test something to the left of negative 2, like negative 3, something between a negative and a positive, and something to the right of 5. And let's throw them in one by one. Negative 3 minus 5, negative 3 plus 2 quantity squared. So I got negative 8 times negative 1 squared. Well, negative 1 squared is a positive 1. Is negative 8 less than 0? Yes, it is. Throw 0 in. 0 minus 5, 0 plus 2 squared. Negative 5 times 4 is negative 20 less than 0. Yes, it is. Plug in 6. I got 1 times 8 squared is 64 less than 0. No, it's not. False. So it looks like our solution here would be from negative infinity up to negative 2, not including the negative 2, right? That's open. And then we're going to go from negative 2 up until 5. Again, we're not going to include that 5 either, right? And if I was thinking about this visually, you've got x minus 5 times x plus 2. If I was multiplying this out, right, I'd have x minus 5 times x squared plus 4x plus 4. So I have x cubed, blah, 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 blah. Right? This is our function. So it's got this end behavior where it goes down to the left, up to the right. It's got critical points. It's got 0 at 5 and at negative 2 with multiplicity of 2. There's 2 of them there. So it's going to come up. It's going to like touch this. It's going to come down. And it's going to have to come back up again, right? And so where is this thing? Less than 0? From negative infinity up until negative 2, but I can't include that negative 2, and it's still below it, clear until 5, but I'm not going to include the 5 either. I should have boxed that solution there. All right, let's do one more polynomial inequality before we get into the rational inequality. So here it looks like we have a 4th degree polynomial. Where's this 4th degree greater than 0? Again, I'd get my critical points, set each of these equals 0, get my critical points, so I get x being 0, x being 5, x being negative 7. That would be on my testing interval, negative 7, 0, and 5. Now this is strictly greater than 0, so when I plug those in, is 0 going to be greater than 0? No. When I plug 0 in, is 0 going to be greater than 0? No. Is 5? When I plug 5 in, I'll get 0 being greater than 0? No. So I'm not going to include those because I do not have an or equal to. If I had an or equal to, I would fill all those in and I would include them. Oops. And now we would just want to go through the process of testing. So let's test negative 8. How about negative 1? How about 1? And how about 6? So I have negative 8 being squared, negative 8 minus 5, negative 8 plus 7, So I have 64 times a negative 13 times a negative 1. Now, a negative times a negative is a positive. Positive times a positive, 64 is a positive. Is a positive number greater than 0? I'd say yes, that is true, right? Now I throw a negative 1 in. So I got negative 1 being squared, negative 1 minus 5, negative 1 plus 7. So I got a positive 1, negative 6, positive 6. Is negative 36 greater than 0? That is not true. Plug the 1 in. Is negative 32 greater than 0? That is not true. And finally, throw the 6 in. Positive times a positive is positive. Is a positive number greater than 0? That would be true. So this will be our solution set. Would be from negative infinity up until that negative 7. I cannot include negative 7. And then the other true part is from 5 on. Do not include the 5. Right? Now, if I was thinking about this visually, this thing hits at 0 with multiplicity 2. So it's just going to touch it from below or above. It hits also at 5, and it hits also at 7. Now they're going to cross through those one way or another. They're going to cross through those, not just touch them, because they're odd. There's an odd multiplicity there. In behavior, this is an x to the 4th. A positive x to the 4th is the very first term. So I know it's going to go up to the left, up to the right. So it's going to come, it's got to cross through here. It's going to come up. It's just going to touch right there, and it's probably going to cross through again. So hopefully you can see that that is where that statement is positive. That's where the function is above greater than 0. The x-axis, right? Not including the zeros there, if you were to graph that. Now notice we've got a rational function on this left-hand side, right? So we're asking, where's this rational function less than or equal to 0? We're going to go through the same process and find our critical points first. That's our zeros and where it's undefined. So where's our zeros? Well, if x minus 2 equals 0, that would be 0 over whatever. If x plus 1 equals 0, that's another 0. So I have 2 and negative 1. And then where is this undefined? Well, that comes from the denominator, right? This is where I'd have a vertical asymptote. At 4, this thing is undefined. So those are all going to go onto my testing interval. I have negative 1. I've got 2, and I've got 4. And let's think about these one by one again. If I throw negative 1 in and I test it, is 0 less than or equal to 0? Is 0 less than or equal to 0? And you say, yeah, it is, right? So for the zeros, being the 2 and the negative 1 from the numerator, the 2 and the negative 1 from the numerator, right? We could do the same thing with the 2. The 2 would make it 0 less than or equal to 0. I'm going to include them because it's an or equal to. Because it's an or equal to. Now the 4 is different. The 4 makes this thing undefined. Let's go ahead and test the 4. If I plug 4 in, I got 2 times 5, I got 10 over 0. Remember, this is undefined. I can't do that, right? There's no way I can include the 4. It's not even in my domain. So it can't be part of my solution. It's not even defined on the original rational function, right? So I'm not going to include anything where it's undefined. Can't include that as part of my solution. Now let me erase this and we'll get through. Now let's go ahead and test to the left of negative 1. Let's try negative 2. Let's try between them, and to the right of 4. We're going to test it one by one. So negative 2 minus 2, negative 2 plus 1 over negative 2 minus 4. Is this less than or equal to 0? So negative 4 times negative 1 over negative 6. So I got a 4 over negative 6. That's negative 2/3. Is that less than or equal to 0? Yes, it is. Negative 2/3 is less than or equal to 0. Let's throw a 0 in. 0 minus 2, 0 plus 1, 0 minus 4 is negative 2 times 1 over negative 4 is a positive a half less than or equal to 0. No, it's not. Plug the 3 in. So we got 1 times 4. I got 4 over negative 1. Is negative 4 less than or equal to 0? Yes, it is. Now let's throw 5 in. I got 3 times 6, 18 over 1. Is 18 less than or equal to 0? No, it's not. Okay. So my solution here would be from negative infinity up to negative 1. I have to include negative 1, right? I got to fill in there. Not between them, that's false, but I can go from 2, including 2, up until 4. Including 4, right? If I was graphing this, well, actually, we'll just pull up the graph of it on decimal. Hopefully you can see that this rational function has a I should say vertical asymptote x. Let me put x equals 4 on there. Imagine that that's a dotted line, that blue x equaling 4. And then you can see the red function, right? So notice that it is less than or equal to from negative infinity up until that negative 1 that we had. And we include the negative 1 because it does hit it right there. And then from 2 until 4, and then it's not showing it out here to the right, but to the right, see how it's also, or we're not less than or equal to anymore. So just 2 to 4, not including 4 because 4 was where we had the vertical asymptote. All right, so it matches our algebra. This would be a good you try problem if you want to pause the video, you guys. All right, if I was doing this, I would go ahead and factor the numerator there, difference of squares, and find our critical points. Where's our critical points at? Well, our zeros here would be from the numerator. This thing is undefined. The other critical point from the denominator, right? That's where this has a vertical asymptote. So we got x equaling 2, x equaling negative 2, and x equaling 3. So negative 2, 2, and 3. Now, do I want to include the negative 2 and 2? Well, if I was checking that, negative 2 minus 2, negative 2 plus 2 over negative 2 minus 3, is that greater than 0? Well, I have negative 4 times 0, 0 over negative 5. Is 0 greater than 0? No, it's not. So I'm not going to include my zeros, negative 2 and 2, because 0 is not greater than 0, right? If it had a line underneath that inequality, I'd include those. And then the undefined one would be 3 minus 2 is 1, 3 plus 2 is 5, over 3 minus 3 is 0. Again, I cannot divide by 0, so there's no way I'm going to include the undefined point. That's that vertical asymptote, so it can't be part of the solution. So let's get to the checking part now. About negative 3. So negative 3 minus 2, negative 3 plus 2, negative 3 minus 3, is that greater than 0? I get negative 5 times negative 1 over negative 6 is 5 over negative 6. Is that greater than 0? Negative 5, 6, greater than 0? No, it is not greater than 0. Let's test about 0. 0 minus 2 is negative 2. 0 plus 2 is 2. 0 minus 3 is negative 3. Well, negative 4/3 is a 4/3. Is that greater than 0? Yes, it is. Let's plug in something between 2 and 3, like 2.5 or 5/2. So 2.5 minus 2 is a half. 2.5 plus 2 is 4.5 or 9/2. 2.5 minus 3 is a negative a half. So I've got a positive over a negative. Is that greater than 0? No, a negative number is not greater than 0. So that's going to be false there. Let's plug in 4, something to the right of 3. So 4 minus 2 is 2. 4 plus 2 is 6. 4 minus 3 is 1. Is 12 greater than 0? Yes, it is. So my solution set for this would be from negative 2 to 2. Now I cannot include either of those. And then from 3 on, do not include the 3. Of course, you could look at it visually if you wanted to verify as well. Now this one, we've got another annoying one. It's not greater than 0. We need a 0 on the right hand side. So before I even start this, I got to subtract 1 on both sides. And then I got to get a common denominator. So this is minus 1 over 1. Let's get a common denominator of x minus 4. So I've got x plus 2 minus x minus 4 all over the x minus 4. So I got x plus 2 minus x plus 4 over x minus 4. So I got 6 over x minus 4. Okay, that's what we're trying to answer. 6 over x minus 4. Where is this thing greater than 0? Well, my critical point, there's no zeros here. Notice there's no x in the numerator. It's just an undefined point from the x minus 4. So x cannot be 4. So on my testing interval, it can't be 4 because that makes this thing undefined. But we're going to have to test around that. So let's go ahead and test like 3 and maybe 5. And we'll throw it in. 6 over x minus 4 greater than 0. Is 6 over negative 1 is negative 6 greater than 0? No, it's not. 6 over 5 minus 4 is 6 over 1 greater than 0. Yes, it is. So our solution set will be from 4 on, not including 4. And of course, if we were graphing this, where is 6 over x minus 4 greater than 0? It has a vertical asymptote at 4. And hopefully if you plugged in a few points, you'd see something like this. You can see that it is from 4 on, it is greater than 0. Right? Similarly on this one, we got to get this with a 0. So we're going to have to subtract 2 first before we even start this. Subtract 2 is less than or equal to 0. That's 2 over 1. Get our common denominator. So we got 3x minus 3 minus 2 times x plus 1. This is all over x plus 1, less than or equal to 0. Distribute that. So we got 3x minus 2x is x. Negative 3 minus 2 is minus 5. So I got x minus 5 over x plus 1 is less than or equal to 0. So what are my critical points? Well, my zeros are from the numerator there. So I got 5. Where's this thing undefined? In other words, where's our vertical asymptote on this thing? At negative 1. So when I'm testing this thing, 5, negative 1, do I include the negative 1? Well, the negative 1 causes this thing to be undefined. Negative 1 minus 5 is negative 6. Negative 1 plus 1 is 0. That you can't divide by 0, so there's no way we're going to include that negative 1. What about the 5? Well, 0 over 6 is 0. 0 plus u is 0 less than or equal to 0? Yes, it is. So we're going to fill that in. So we're going to include the 5. Now let's go ahead and test test some points and get that to erase maybe. So -2. Let's throw it in. -2 minus 5 over -2 plus 1 is -7 over -1. Is 7 less than or equal to 0? No, it is not less than or equal to 0. Something between -1 and 5. How about 0? 0 minus 5, 0 plus 1 is -5 less than or equal to 0. Yes, it is. How about 6? To the right of 5, let's test 6. 6 minus 5 is 1. 6 plus 1 is 7. Is 1/7 less than or equal to 0? No, it is not. So our solution set goes from a -1, not including -1, up until that 5, but it's filled in on the 5. And of course, you could take a look at the graph of x minus 5 over x plus 1 if you wanted to. In fact, we could briefly do that. X minus 5 over x plus 1. It's got a vertical asymptote at -1. The degree of the top is equal to the degree of the bottom, so the horizontal asymptote be y equals 1 over 1. And then you could plot around that. It looks like you hit at 5. Hit at 5. And you are less than, so you could graph this. I think this one's over here, something like that. So plug some points in, double check that, but that's what you should see approximately with your graph. Thanks so much for taking notes. See you next time.